Thank you for carving out a little bit of your time here at Dell World to learn a little bit. Today our goal is to just educate you guys on something called composable infrastructure. So my name is Sumit Puri. I'm the CEO and co-founder of a company called Liqid, and our mission is to turn the data center to dynamic. The technology that we've developed and that we've implemented is something referred to as composable disaggregated infrastructure. We'll explain exactly what that means in just a couple slides. But the problem that we're looking to address is around resource utilization of hardware inside the data center. If we take a look at how much the very expensive hardware that we're deploying in our data center is actually used, the numbers are very low. And the reason why these numbers are very low for the amount that the hardware gets used is because the world is static. We currently buy our servers, we configure them at the point of purchase, we deploy them into our data center, and they pretty much stay that same configuration for the life of the environment. But the world is changing, our workloads are changing, our workloads are evolving, they're getting bigger, they require more resources. So if we take a look at what Gartner is saying is we're on this evolution of the data center, turning the data center from static infrastructure to dynamic infrastructure. Originally it was things like 3-tiered architectures. Today the big buzzword is things around hyperconvergence. The next phase of this entire chapter is something referred to as composable, disaggregated, dynamic infrastructure. And what do we mean by composable infrastructure? By composable, we don't build our servers by plugging devices into the sockets of the motherboard. With composability, it's all about pools or trays of resources. Imagine a tray of CPUs, a tray of SSDs, a tray of GPUs, a tray of networking devices, a tray of FPGAs, a tray of networking cards, it doesn't matter. Rather than plugging those devices into the sockets of the motherboard, we connect those devices into a fabric. In our situation, a PCIe fabric or an Ethernet fabric. And then when we come in, we come in with software and we dynamically orchestrate or compose servers at the bare metal. Grab this CPU, grab me those 4 GPUs, those 8 SSDs, and build me a server, just like you were plugging in the motherboard, except you're defining it in software, and on the other side, you're getting delivered infrastructure of any size, shape, or ratio that you need. And that infrastructure is dynamic. So when my server needs another GPU, we don't send a guy with a cart to power stuff down. We reprogram the fabric and add or remove resources dynamically depending on what your application requires. So that's how we define composability. Our core technology is around the software layer that allows you to orchestrate, and we have some fabric technology that allows you to interconnect the off-the-shelf hardware. We're big partners of Dell, and we use a lot of Dell hardware to deliver these composable solutions to the market. Couple of use cases. One of our customers is a transportation company. And for them, what happens at 5 p.m. is very different than what happens at 2 in the morning. And right now they play a game of workload matching. Small workload, small server, everyone's happy. Small workload, large server, we're wasting thousands of dollars on underutilized hardware. So what they said is we want to take a new approach. We want to study the workload as it comes in, spin up small, medium, large, extra large, whatever the application requires, get the work done, and as soon as the work is done, free the resources back into the pool, right? This is how they're going to increase the utilization of something like a $10,000 GPU from 20% to 40% to 60%. And if I can take the utilization of a very expensive resource and raise it from 20% to 40%, does that mean I'm buying less hardware? Does that mean I'm doing more with less? We believe there's a case there. And for this customer, it's not even a matter of am I going dynamic or am I going static? They're 100% convinced that dynamic infrastructure is the future. Their question is, am I going AWS public cloud or am I going to do this on-prem? And what we offer with composability is the ability to get all that agility, flexibility that you get from public cloud, except we can do it on the hardware and the infrastructure that you're responsible for. And we can save you a lot of money doing it. These GPU instances on AWS, yes, they're very easy to spin up, but guess what? They're not very cost effective. So before you know it, the AWS bill can become very large when you start thinking about next generation workloads that leverage a GPU and FPGA and other very expensive resources. Another use case for us is a media and entertainment company. During the day, they have these GPUs and they give them to their AI engineers. When the AI engineers go home at night, they reprogram the fabric and they use that same hardware for video rendering. So out of the same $50,000 piece of hardware, they're getting 100% additional utilization out of it. This is not possible unless you have dynamic, composable, software-defined infrastructure, because I can promise you, nobody at 5 o'clock at the end of the day is gonna go reconfigure hardware before they go home so they can do additional work. This, you set a policy in place that says at 5 o'clock at night, when that hardware is not being used, automatically reprogram it and go give it to somebody else. Okay? AI is a big deal, right? Everyone's talking about AI, but when we think about AI, AI is not an event. AI is a workflow. First we ingest, lots of networking. Then we're doing cleaning and tagging, lots of CPU. Then we're doing training, that requires multiple GPUs. Then we're going to inference, and inference requires a single GPU of a different type. And at the center of all this is the data. You can have a petabyte of data. Data's got gravity. Why are we moving data around? Let's leave the data in place and move the compute, GPU, networking resources to the data. So what we're developing in conjunction with Dell is a composable AI platform. A single SKU that you're gonna be able to get from Dell that enables you to do all of your AI workflows. So this is a single package that we're gonna be announcing tomorrow in partnership with Dell. We have two big announcements at this show. Number one is we are now OEM partners with Dell. So you're gonna be able to buy all of the Liqid solutions like the AI pod that you see here on the screen directly from Dell. They'll finance it, they'll warranty it, you'll have a single place to go to get these solutions. But this solution here will have 4 compute nodes, 8 GPUs, and 32 terabytes of NVMe. And you're gonna be able to do an any-to-any composition. Grab any node, connect any amount of GPU with any amount of SSD, and dynamically change that as you go through your AI workflow. Very excited about this. The next big announcement that we're announcing at the show here today is around multi-fabric support. So when we started Liqid, our primary fabric of choice was PCIe. We were running PCIe up and down the rack and across multiple racks because PCIe is that native interconnect that everything in the data center is speaking. When storage moved to PCIe and GPUs became relevant, it was a data center first. It was the first time storage, compute, networking, GPUs, FPGAs all spoke a common language, and that was PCIe. That's what allowed us to compose at the bare metal. Now, the announcement we're making at the show here this week is multi-fabric support. So you're gonna be able to support PCIe fabrics, and you're gonna be able to support InfiniBand and Ethernet fabrics, all from a single pane of glass, and cross-compose against these fabrics. So you'll have a fabric of PCIe devices, grab what you need, connect it to the server. You'll have a fabric of Ethernet or InfiniBand devices, grab it what you need, connect it to the server, all through the Liqid Command Center software. So guys, I believe, okay, where are we selling this stuff? Where are the homes for it? So number one, we talked about AI, machine learning, deep learning, anything that's leveraging these next generation accelerators, we're a natural fit for it. I can't buy a server that has 16 GPU sockets, but I can compose one as big as I need. The AI stuff is very important for what we're doing. Cloud, right? Not everything is going public cloud, contrary to popular belief. If you're a large financial institution or a healthcare company, probability is you're not putting medical records or financial records on public cloud. What if we could give you the flexibility on the infrastructure that you own that you're getting from public cloud, except do it on-prem? So people building clouds, whether you're a cloud service provider or whether you're building a private cloud, there's a natural fit for it. High performance and clustering. There's nothing lower latency in the ecosystem than PCIe. People get excited about Ethernet being a 15 microsecond low latency interconnect. PCIe latency is 150 nanoseconds. That's not 10 times faster, that is 100x lower latency. Deployments, for example, at the base of an antenna tower. And what do those guys care about? They care about power, floor space, cooling. If we can raise the efficiency of the hardware from 20% to 40%, does that mean we can do with one rack what we used to do with two? Maybe. Let's have a discussion, right? And then the other one is it's very difficult to send somebody out to the edge to reconfigure hardware. Send a guy with a truck to the top of the hill to change out a GPU, painful. With software defined, we can reconfigure the edge depending on what the application requirement is. So I know that is my last slide, so I'll open it up to any questions. Charge back type feature? No, right now we're selling complete solutions, and that would be up to something like the cloud service provider to understand how they would want to monetize it.
Like a hybrid cloud type of configuration. I'll have internal users specking servers out for it. That's what I meant, like a charter.
Yeah, so that's what we expect. We think everything is going to be hybrid cloud in the future, right? Everything is going to be a mix of some amount of infrastructure on-prem, some amount of infrastructure on the cloud. So what we have the ability to do is give your internal IT department Amazon-like capability for the infrastructure that they own. Right?